Now you can share your screen and start.
First, I will talk about some functions, how to write a function in Python, and discuss how to write the data to the output file and how to read the data from the output file in Python. So, start IPython with pylab flag. So, in the Python function, define that by f command. And the function name, let us say function name is f name and its arguments. Let us say I want to add two numbers, that is a comma e, and this is now I assign the variable which I can write this output. So I write summation equals to this a plus b and return the output to the function to the screen. Return summation and enter. Now this function is defined. How to call this function? You could assign a variable name, or you can directly call this function using this f name. That is f name a comma b. Write here f name and assign the values of a comma b. I should let us say a is 1 and b is 10. When you enter this, the summation of these two numbers appear on the screen. And how to write other functions, like let us say I want to write Coulomb function or Coulomb potential for a two-charged nuclear system. So how I assign those variables? Let us say define, that is def v Coulomb Coulomb and its arguments. Let us say we have the two charged nuclei, that is the atomic number Z1, comma Z2, and the separation, that is from where to where I want to calculate the potential from R initials to R final. And step size I am giving here, that is dr in steps of this. Now in Coulomb potential, we saw that there is a function, there is a value 1 upon 4 pi epsilon naught Z1 into Z2 divided by R. If you substitute Z1, Z2 in units of elementary charge E, you obtain E square upon 4 pi epsilon naught R. In nuclear physics, we write that as a factor equals to, that value is 1.44 or 1.45 MeV Fermi meter. MeV Fermi meter. So this factor is given here. And now I have to assign the Coulomb potential. So I assign Vc is equals to this 1.45 multiplied by Z1 star Z2 and multiplied by, that is R inverse or 1 upon R. I write it R star star minus 1. Before that, I have to initialize the R values. So what will be the R? So I assign R equals to using a numpy function called eRange, which is also used like linspace to generate the numbers. So you may write eRange, and here's the initial points, that is called from Ri to Rf in steps of dr. Okay, I want to use this R function. So I write this Coulomb potential here, Vc, and then plot this function, plot this R comma Vc, okay, and then return this Vc. And now I have to define all those values by calling this function. Let us say I call this VC or called VC, small VC is equals to nothing but this V coulomb. And now you can assign values of Z1 directly here, or you can assign Z1 equals to, let us say this is a proton scattering on helium. So Z1 is 1, Z2 equals to 2, and this Ri, let's say, starts from 2 Fermi up to, let us say, 50 Fermi in steps of 0.1 Fermi. Let us say here, okay. So dr, if you use this Z1 equals to Z2, you have to assign the dr equals to. If you did not write dr, so you have to assign only the values. So the plot for Coulomb potential is here. That is R from 1 Fermi to 50 Fermi. This is the 1 upon R plot. So this is the values. Now we want to write the values of a function to a file. So how to do that? First we write that a equals to something. If you write something in this square bracket, this is a list. If you type this a and then type the command type a, then this assign the value that this is a list and this is an empty list which does not contain any numbers. Okay, this is a list. If you assign some variables, let us say a equals to some DICT, that is dictionary, and in which is assigned by this curly braces, and this is the values of key and corresponding values for the dictionary. Okay, you can assign here that the key value is, let us say, is sign, and the separator is colon, and the values of sign, let us say, pi. Okay. There is error in the dictionary. Okay, I cannot assign the values of dictionary, so I write directly DICT. Something is missing. So let us move to the next to write the plot, to write the data to the output file. Let us say I have some numbers. First, I have to open a file and write the data to that file using the list. Okay. For file equals to, I open a empty file, that is file equals to open, and the name of the file, that is fname dot get the output file which I have to use to write the data, comma with the variable w. It is similar to that of assigning a variables in Fortran. Okay. Now I can assign the values for some other variables, like say for I in, let us say I assign an empty list, that is a equals to list, or list, or directly you can write this for a equals to for that is for I in range 1 comma 11. Okay. That's I for I want to write the I square, that is num square of a number, for using a for loop for I in range. This range is let us say range starts from 1 and the last point is 11 is skipped here, and that n minus 1 digit is there. So if I only write that's a1 equals to range 1 comma 11, and if you type a1, this range a1. Okay, for range this is only the values of a, this displays that a1 is the range, and I can write those values to the here for I square. Yes, for I in range, what is it, item in my list name is a, for item in list, in my list. So write f, that is file dot write. So this is used by command str, that is string of I comma, this is a empty space, comma, this you have to write the comma node, comma, this is a plus sign here, plus the white space is there, plus this str of this I star star 2, and then plus, and you want to write the next number in the new line, so write plus this new line flag and close this bracket, and then close this file dot close. If for I is not is defined. Okay, for there is an item, I decide the item, so I have to write this for this string in item, for item in my list. So this is item star star 2. So I can check where the file is there. The last file name, that is the latest file, fname.dat is there. So I can edit this file or see this file, what is inside this file. Edit fname.dat. Okay. So there are the numbers, that is I misplaced the string variable, that is the backslash is there. I write the forward slash, so the numbers are not there. So there is a n symbol, that is n1, n2, n3, n4 is there. So I can go back and correct that. This is not the forward, this is the backslash. Therefore, for this you can use. So I have to first open that file, so that this is open, name.dat, and this A, and the item in A is this, and these functions. Okay. Now I check again the file, it is there. So %edit. So there the data, that is first column displays the number, that is integer I, starting from this I1, I square in range, and I again write that square, I square, and again I write that square of that number, because list contains the square of the number, that is 1 to 11, and the last number is not there. It is starting from 0 to, actually 0 to n minus 1. The first index is Python is 0, so it is I square is there. And I write again the for list, I write I square, that is I square square, that is 1 square, 4 square, 9 square, 16 square, 25 square, and this. This is the writer data in the multi-column, and you can use this data and how to load the data from this file. So escape :wq. If you have to, let us say we have the data file, we have the dat file or txt file, in which experimental data or the data from our calculation is there. How to load the data from that file? Let us say this, I write the data is equals to, that is there are the two commands. One of this load txt, it is load txt command. Right here the file name of that date. Let us say I have the file name, that is fname.dat, and this load the data file from this present working directory to the Python, and you can say what is the data is. Okay, this is the data files, and it's the shape of it is given in the terms of array. Okay, and another one is that is data one is that is generate from txt, that is gen from txt. Okay, gen from txt, again write the file name here. Okay, then data one, it is again stored in a form of array. And how to plot this data from the file? So you have to write it. Let us say I can write data one, that is plot. Let us say plot first column with respect to second column. So the first column here in Python starts with 0, and the second column is 1, and next one is 2. So I can plot data. Okay, data. This column is for that is skip all the that is include all the rows, but the 0th column, comma, that is data. It's again for that is all the rows, but the first column. So the square versus square plot is there. That is, I have in x-axis, I have numbers from 1 to 100, that is square of I. And y-axis contains the square of those numbers, that is 0 square, 20, 14, 100 square. So this is the way how you generate the data, write the data to the output file, and how to use the data from the output file to visualize or do the other calculations. Sir, it is enough for today?
इट इज़ एनफ फॉर टुडे, बट बिगिनिंग में जो हमने आइटम वाला आइटम डिफाइन की ना, उस लूप को दिखाना थोड़ा सा, उसमें मैं थोड़ा
okay sir, let us say that is this an empty list, so I write the numbers in this list. So let us say I write I star to, so I generate the I square for I in range. So I in range from this will this is a closed interval, that is, this is a closed interval starting from 1 to the open interval 11. The last number is skipped, so this is n minus 1, 0 to n. It's a 10 numbers there are in list. Okay. For I didn't write to I in range. So I, the variable, it might be I, it might be I, it would be each, it might be any other thing. So this is a list, and this list contains the square of the number.
Okay.
So I iterate through this list. First, for writing the data file, I open the data file using this command. This is file open. First, I open this file.
Here, what is the meaning of
write data?
Here, what is the meaning of this W in double quotes?
So, sir, I have to write the data. If I have to read the data, this must be R. If you have to append the data file, this must be A flag. As in Fortran, there is a new file, write file, rewrite, or there is an append option.
I think
so in
yes, Fortran we will give open or yeah, right. It's for the write. W means write.
W means for write. This file is open for the write. So if you have to, I have to append the data file from this. So I write, because this is a file name I have got that with me, and I could append the data file from that last line to the other data structures in that file.
Okay.
So this is for, then I write the data to this, that is string option, that is string in item. So item contains, now item in a list. I am looking for item in a list A. So A list contains the square of all those numbers, and I write the square of those numbers, and then in the next column there is some white space, and again I write the square of that numbers, and then close that.
Here that means the items are these basically 1, 4, 9, 16, 20.
Yes sir, yes sir. This is the item. The initial data structure, which is list.
Okay, and then after that you are taking it square.
Yes, I am writing the square, and again taking the square. So
and this double space, after plus,
plus big space, sir, for white space.
White space.
Let us in Fortran we give the that is width, sir, x, nx, that is the white space, n white spaces.
Okay.
Like that, it is that, sir.
And in backslash is basically
new line, sir. For new line structure, this backslash is new line. That is one data is written, that is I square and I square. Then this control goes to the next line. The data structure is written in the next line.
That means data is written vertically downward.
Yes, sir, vertically downward, sir, because we have to use the data, and it is easy for us to visualize data in that structure.
So yeah, now it's fine. Any question? So I think, thank you, Lalit. I think it helped us a lot, and other audience who are also looking at these lectures. So thank you.
Yes, sir.
Okay, tomorrow we
Thank
will
you,
again meet. Okay, thank you.
Okay, sir. Thank you.
Okay, thank you.